Hello, everyone. Thank you for joining us and welcome to Google Cloud Innovators events on Enterprise Serverless with Google Cloud. My name is Veer Muchandi. I'm an app mod solution manager with Google Cloud on the global solution engineering team. Feel free to ask any questions throughout today's session using Ask a Question or chat features. Agenda for today. First, we'll understand the problems we are trying to solve and why we need serverless. Serverless technologies are generally misunderstood. We'll look at some of the common perceptions. Next, we'll look at what Google Cloud has to offer with serverless. We will then look at some common patterns that the serverless technologies are applied with. Then we'll see the architecture and implementation of these serverless patterns with a sample application and its demo. Let's first look at what problems we are trying to solve. Even well-established enterprises are under the pressure to deliver. They are under the pressure to deliver fast. They are under the pressure to deliver defect-free. They are under the pressure to deliver at lower cost. They are under the pressure from upcoming smaller, more agile organizations that can effectively compete and build faster, as these upcoming organizations are pretty much lean and nimble. Every year, the DevOps Research and Assessment team at Google publishes a State of DevOps report. This report represents more than 7 years of research and data coming from more than 32,000 professionals. This report helps us understand the best practices that lead to excellence in technology. The latest report shows that elite performers do multiple deploys per day with a lead time for changes less than 1 hour. The number of elite performers are also growing. This is a pressure point as enterprises are under pressure to compete with such elite performers. Scaling up infrastructure involves many steps, and it slows down the rapid pace of growth for an enterprise. Also, it is not a one-time thing. You'll need to maintain the infrastructure. Operations and management of this infrastructure is also an ongoing challenge. Reducing the costs is another pressure point. Most of the enterprises that moved to cloud have gone from CapEx model to OpEx model by shifting to cloud. However, the cloud costs are rising as well. Organizations tried to tackle these rising cloud VM costs by refactoring the applications to more efficient containers. But we are now realizing that always running containers also cost a lot of money. So how do we go green with money? Right? That's our next question. The next pressure point is the developer's learning curve. Today's developers are not just Python developers or Java developers who convert business requirements into running code. They also need to figure out how to containerize and run the applications. There is a steep learning curve as they need to catch up with many technologies, and then they need to learn those technologies. And in addition, they have to having to learn their favorite programming language. They need to learn a lot of other things too. Now, as we are writing more code to build new applications, we are adding additional maintenance for the operation teams, right? Wherever possible, you want to avoid writing extra code that creates additional technical debt. I hope you can relate to most of these issues that we just talked about. Let's now see how Google Cloud's serverless technologies come to rescue from issues that we discussed so far. With serverless, you get fully managed infrastructure. No time is required for initial infrastructure setup. Maintenance and patching are offloaded to the cloud provider. Google Cloud is not just function as a service model. On Google Cloud, serverless and containers go together. Containers prevent vendor lock-in. As you know, Google is always about portability and freedom. Containers provide that freedom to move your workloads. When you build containers on Google Cloud, the resultant containers are Open Container Initiative compliant. which means that they are standard portable containers. Or if you have already built your containers, just bring them and run. If your developers are new to containers, then don't worry about it. There is no need to learn Docker, Kubernetes, or other tools. You can just focus on meeting your business requirements by writing code in one of the favorite languages, such as Golang, Node.js, Python, Java, .NET Core, or Ruby. With Google Cloud Build Packs, the containers will be automatically built from that code that you write in one of these languages. With serverless on Google Cloud, your application can scale on demand and to n number of instances without you worrying about how do I manage the infrastructure based on the upcoming traffic. When there is no traffic, the number of instances will scale down and save you the costs. If you're worried about, let's say, cold startup because you don't want to scale down to zero and your application takes longer to start, then don't worry about it. You can actually scale down to minimum number of instances instead of zero so that you have some warm instances that are ready to take traffic. Another advantage is that you don't need to plan for your capacity well in advance and get the infrastructure ready. You only pay when your code is running and when there is traffic coming in. So, and actually you are billed only to the nearest 100th millisecond. Google Cloud Serverless offers a way to secure your services to be accessible by specific users. You get out-of-the-box HTTPS if you want to enable that. Securing your ingress and egress is offered. Ability to deploy only trusted images. Integration with Secret Manager to mount secrets. Running your containers in secure sandboxes. Ability to configure custom domains and a lot more, right? You get all the security features built into Google Cloud Serverless. Google defined site reliability engineering, in short, it is called SRE, best practices. And you know this, that the industry has followed SRE best practices. Google serverless technologies are designed based on these best practices, such as continuous delivery, horizontal scaling, monitoring out of the box, continuous rollouts, canary deployments, rolling deployments, and many more. These are all best practices that are part of SRE. And we have implemented all these best practices as part of serverless technologies. So now that we understood why Google Cloud for Serverless is important, let us discuss some of the common misunderstandings people have or the perceptions that people have about serverless technologies. Let's wear the hat of doubting Tom. So some people think that serverless is only for small workloads and enterprise-grade serverless applications are not viable. But it is not true. We can build robust enterprise-grade serverless applications. And I'll be actually showing a demo of such an application today that we have built to show it as a sample or an example that you can learn from. You can't connect to applications in private network. That's another common misunderstanding. You can actually connect using serverless VPC connector to the services that are running on your private network. People think that serverless is not for stateful applications and you can't save data. Again, that is not true. The data can be saved from the serverless applications too. You get different kinds of storage technologies like GCS, as well as SQL and NoSQL cloud-based databases as choices for you to save data. People think that you will be constrained by cloud providers' language choices. But with Google Cloud Serverless, that is not true. You can bring any containerized application and you can run. You can't execute long-running tasks like jobs. That's another common misunderstanding. Running a job or long-running transactions is very much possible with Cloud Run jobs that we have introduced. These Cloud Run jobs will actually run your job until completion, and then they'll quit once the job is complete. Let us now get a little bit more deeper to understand what is this Google Cloud Serverless that I've been talking about. Google Cloud offers everything that an enterprise needs to solve those your business problems, right? We have runtimes such as Cloud Run and Cloud Functions. With Cloud Run, you can actually bring any containers and run, right? Or you can build your containers and run. With Cloud Functions, that provides more of a function as a service kind of a model. Runtimes such as the eventing and workflow technologies, which is another area, these drive you towards event-driven, loosely coupled architectures that make your microservices evolve independently. Workflows encourage configuration over code, which is one of the problems we were talking about before, and to create long-running processes with step-by-step execution model. Scheduler allows you to run cron jobs on cloud. So think about running your cron jobs to evoke your applications when you want them. You can run those on the with Cloud Scheduler. From the databases perspective, we do have traditional database kind of databases that are available on cloud with Cloud SQL, and it offers different flavors such as MySQL, SQL Server, or Postgres. We also offer cloud databases. A recent introduction, this happened just a month ago, is highly PostgreSQL database, and it's called AlloyDB. Scale cloud spanner. We also have Firestore, which is a database that can push updates to your front end, and that enables you to build dynamic applications and also mobile applications. Software delivery of applications is another area. So with software delivery of serverless applications, you are handling the delivery of your applications. The build and delivery model of these applications are also handled in serverless way using technologies such as Cloud Build. The CI process runs on cloud, and it only consumes resources when your build is actually running. Also, Google Cloud offers artifact registry to store container images that are built through this CI process. The images can be scanned as soon as they are pushed into the registry to identify any vulnerabilities. Over and above all these, you can integrate with best-in-class analytics, AI/ML, first-party services easily from serverless applications, such as being able to analyze for example, images and content, speech-to-text, video intelligence, and things like that. A few examples of such first-party services that you can integrate with are shown here, but there are many more. These services will help you venture into use cases that you may not have imagined before on where you can take your enterprise. Such integrations will truly allow you to take a leap jump into technologies that allow you to effectively compete in this industry, right? This where you are undergoing rapid changes, and you can actually take that leap jump that you need to. So let's think about some common patterns that we have derived based on Google Cloud Serverless technologies. These patterns are based on how our customers have been using Google Cloud Serverless technologies. In our work with various customers across multiple industries, we have identified this series of common patterns, and these actually regularly show up in those architectures. The simplest use case around applying serverless technologies is around website hosting. You can run both static and dynamic websites and reduce the costs of hosting. The key thing here is Google's global networking and CDN, along with regional data centers, makes it super attractive. Another pattern, enterprises adopting serverless like to take an incremental approach towards adopting these new technologies. In the meanwhile, they actually want to connect to their serverless applications that they are building. They want to connect to their private relational databases that are in their own network, right? Being able to access these private databases or other microservices that are running on the private network from Cloud Run through VPC connector is another common pattern that we are seeing. As enterprises begin adopting serverless technologies, they often see the value of utilizing fully managed cloud databases in their applications. This often reduces operational overhead and increases reliability. Google offers SQL, NoSQL, document-based, and key-value databases to meet these needs. While using serverless for simple hosting increases agility for organizations, enterprises often require additional measures of security to lock down access to services they deploy. The integration tools that will help you reduce the effort to accomplish this, as well as increasing the overall security of the system. So we provide a secure ability to actually secure your services that are running as serverless as well. With the increased in flexibility of computing processing that is available on the cloud, organizations actually begin to adopt the event-driven architectures that allow you to do distributed processing, and you can integrate different systems based on the functions required at the point of time. By utilizing the event-driven architectures, organizations like yours can more effectively scale to meet the demand while reducing the costs of over-provisioned and underutilized systems. Enterprises are saddled with many integrated systems and complex organizational processes. Often technical processes are put in place to call multiple disparate systems in a specific defined sequence as a step-by-step approach, right, to accomplish a larger objective. These workflows may need to work with long-running external systems. You may have to execute steps one by one, or you may have some manual interventions in between, right? And these transactions take quite a long time. So with fully managed workflow services, organizations can reduce overhead and increase effectiveness of these systems. Specifically, doing this workflows with configurations over code will actually give you advantages of not writing extra code to be able to accomplish these things. Most of them enterprises are familiar with batch jobs that process data on a specific schedule. So as organizations move into the cloud, they are wanting to do similar things that run on a specific amount of time, and they have to complete a particular amount of job, and after that, it should go down, right? This is to reduce the operational overhead and simplify systems. So this is another common pattern of scheduled processes. Data is everywhere in the enterprise. In the past, to tap into it, organizations have to stand up complex infrastructures, and which are pretty expensive, right? And this requires specialized teams to stand up and manage those platforms. As enterprises move to cloud, they are adopting fully managed serverless solutions for data pipelines and analytics, reducing the operational overhead and allowing the organization to focus on platform rather than actually maintaining this infrastructure is what Google Cloud offers. So we bring in those data analytics platforms completely out of the box, and you can just go ahead and adopt it. To showcase these serverless patterns that we just discussed, we'll be creating we have created a sample application, and the name of that app, we called it Cymbal Eats. Let's look at that. Cymbal Eats is an eatery. Customers shop for food items on Cymbal Eats. They look for the menu, they order the food through the web and mobile front ends. Once the order is placed, customer can track the order progress. A current status is always up to date on that order when the customer looks at the order screen. This application also offers an employee front end for internal users such as a chef, inventory manager, and others Chef can monitor the orders, pick them up to process in the kitchen. Chef also updates the order status as the food is getting ready or if it is ready to get delivered. The inventory manager can add new menu items to the menu that when the menu needs to be expanded. Now the inventory manager can also look at and update the inventory status. Here is the logical architecture for Cymbal Eats. We have two front ends, one for the customer and the other for the employees. Customer can inquire on the list of menu items through menu service, place an order with the order service. The employee front end is used by a chef to pick up an order to cook and update the order status. The inventory manager manages the menu items and maintains the inventory. Menu service, inventory service, and order service, these are the three different microservices that offer microservices for those respective functionality, right? This is the modular approach. When the new menu items are added, additional processing needs to be done because we are actually adding images. The processing will actually generate thumbnails for these food images and also verify that the images that the inventory manager uploaded are actually food items, right? That processing will happen in the process menu additions on the top that you're seeing there. Post-order processing is triggered for long-running tasks such as, let's say, rewards calculations. Once the order is created, it actually goes and triggers the post-order processing. That's on the far right bottom. Data analytics can be done on the historical order data, and inventory reconciliation would be a periodic task to execute as a job. Now, logically, these services can be mapped to different serverless patterns that we discussed before. As an example, we want to secure the employee UI so that only the employees such as chef and inventory manager can access it, whereas the customer UI should be open to public, right? So that anyone can order. Similarly, we have private database access pattern. We have serverless database access pattern. We have event-driven processes. We have workflow management. And these are all mapped to different modules that we have discussed in the last slide, right? So the things that you saw on the previous slide, each of these boxes are actually mapped to the individual patterns that we discussed before. Now, this is the implementation architecture with technologies coming from Google's serverless stack. Most of these microservices are Cloud Run based. We also have Cloud Functions as part of this architecture. So you have, for example, in the secure access area, you have the Cloud Run service that is being protected by identity-aware proxy. You see that we are using Cloud SQL as a private database that is exposed as a PostgreSQL database to Cloud Run. This gets connected through the serverless VPC that I talked about before. We have the cloud-based database access, global large-scale database such as Cloud Spanner being connected to the inventory service. We also have a Firestore database where we are storing the order data, and this order data gets reflected as the order status is updated. It gets reflected immediately on the front end. So we'll be showcasing all these different patterns in this architecture with an application being put together. It's a complex enterprise-ready application, but all these patterns coming together will build an enterprise application for you. It's time for us to switch over to the demo of this application. So give me a minute for me to actually bring up the demo. I'm starting to share my screen for the demo. And And what you're seeing here, give me 1 second until the screen comes up. All right. So what you're seeing here are a bunch of different microservices that are shown on in the architecture that I just showed you. So you see the different parts of the architecture. All the microservices that I showed here are appearing on the cloud console, right? These are different cloud services. There are also there is also a cloud run jobs, and there is a cleanup service which runs as a job. I'll showcase that as well. So let's look at a couple of services, right? The first one is a customer UI, and this UI is exposed to all the users who are able to make orders. So this is the customer interface. I'll click on this. It opens a new window. Let it come up. In the meanwhile, I'll also open the employee UI, and this employee UI, as we discussed before, will allow employees such as chef and inventory manager to use. So I'll split it out as two separate windows so you can see what happens in both the screens. So the first things first, let's look at, as I said, Cymbal Eats is a food application. If your mouth is watering and it is lunchtime for you for some reason, don't blame me. This is all food. I understand that. Let's order some food, right? So this is, let's order a sweet. But before I order, let's look at the chef's viewpoint. On the right side, I have the employee UI. And as a chef, I'm looking for, if I'm getting orders to actually prepare food, right? There are a couple of orders that are already complete and they are picked up yesterday. I just opened the store and customer is actually making an order. So I'm wearing the cap of a customer and I'm clicking on this order. I'm ordering a sweet and I'll just leave the delivery address for Angela and I'm ordering with GPay. Let's complete the order. And there is a new order that got created here. And you can see immediately that the order appears on the employee front end. I didn't even have to go and refresh the screen. As soon as I created the order, it appeared immediately, right? That's the advantage of using the Firebase in our architecture. Again, let me show you how it is connected. Sorry. So if you see the order service is a Cloud Run service with Firestore in the backend. The Firestore, once you create an order, it adds an order to the Firestore, and Firestore immediately updates both the employee UI and the customer UI as the order status changes, or once an order is created, right? That's the advantage. It's pretty much dynamic. Let's actually see the employee, right? So as a chef, I'm actually picking up this new order, right? I can either start preparing this order or I can cancel and refund in case I don't like to prepare this or whatever, right? So let's start preparing this order. I'll click on start preparing and the order status changed to being prepared on my screen as a chef, but also if the user is looking at it, the consumer is actually looking at it, even for them, the order status got changed to being prepared. Right? See that? Or I'll change the status again to ready for pickup. It is ready for pickup in both places, and once it's picked up, again it's changed, right? So basically, if you want to build dynamic applications, we have actually built that example in this sample demo application. So you will understand how to build such applications using these serverless patterns that I just showed you. Okay. Let's look at another example. Now I'll bring up let's look at the menu items on both the screens. Our menu only has 4 items here, right? Let's add more items. So as an inventory manager, I want to manage the menu and I want to create a new menu item. right? So when I create the new menu item, and there is a reason why I'm showing this. I mean, the functionality of this application itself may not be relevant to your business, but I'll actually show the technology that is acting behind the scene. So bear with me for a minute as I create this new menu item. So I create a new menu item. Let's say we want to add a new food item. So let's say we'll add healthy bread or millet bread with curry, let's say. And item price, let's say it is $4.50. Spice level, we'll make it spicy. Create a menu item, and I'm choosing an image for the food item, right? So let's say from the food images, I'm choosing a food item and I'm uploading that image and I'm submitting it. And it says the menu is being processed. Let's go back to our home page, manage menu. And you see that, oh, the processing is already done and the food item got added and it is ready right now. That healthy bread that we added, it is ready right now. Let me adjust the inventory to say how many food items do I have to sell today. Let's say I have 10 items to sell today and I adjusted the inventory. And when I see that, I'm also seeing with the spice level 4, that healthy bread, the millet bread, is available on the menu for customer to order, right? Now, this is not interesting. What is interesting is what happens behind the scenes. So when I actually process this item, let's see what happened under the covers. So we have to look at let's go back and quickly look at the architecture of this app. When I use the employee UI as an inventory manager, I created a new menu item which accessed the menu service and it added a record here. But I also uploaded an image. The image gets stored in the cloud storage, and it triggers through the asynchronous mechanism like event arc. It actually triggers cloud functions, and this cloud function is actually calling a Vision API for two reasons. One, to generate a thumbnail image so that we get a smaller image to be used as part of our application, as well as it also verifies and makes sure that it is a food item. So let's look at the process thumbnails cloud function, and we'll see the logs. It's loading up. So the function got executed here. I'll make it a little bigger so that you can see it properly. So you can see that it actually called the Vision API. And what is of interest here is Vision API, which is offered by Google as a first-party service that has nothing to do with our actual microservice. The microservice, the cloud function actually called the Vision API to analyze the food image, right, in that event processing. And the labels that it received back are that it is food, there is tableware, there is dishware, and things like that. So based on that, our function is actually, let's look at the source code, is verifying that it is either the label is actually a food or juice, and only then it will allow. If it is something else, it won't allow. So let's actually make sure that it's working like how we intend it to be. I'm going to upload an item, create a new menu item, which is not food. So let's say we upload a new item like get into a car, pick up food. And what I'm uploading is a car image. Let's see what happens if I upload a limo image. So we'll go back to our menu, and it's not showing up here, right? So let's display. It is currently display read-only items is checked. I'll uncheck it to see what happened to our car. So the status of this guy is still in processing status. So let's give it a minute. The status shows that it has failed, right? Let's go back to our cloud function and look at what happened in our logs. So in this case, when you see the logs, the Vision API labels have sent wheel, vehicle, tire, car, and other things, right? So it was exactly telling you what is inside an image. So think of what these first-party services can do you, right? You can verify the images. You can do speech to text. You can do things like video processing and all. So basically, imagine how your business can transform from what you are doing today, writing simple applications, to be able to process other things as well and take your business to the next level by being exposed to these kind of APIs right from your serverless applications when you use this technology, right? That was what I wanted to show you. So now, as you can see that there are a bunch of items that I had uploaded before that are in this failed status. You can see I uploaded containers image that is in failed status. There is a crane that is in failed status. So these are in failed status for quite some time, right? So let's see if we can actually, there is a cloud run jobs. I'll reduce this a little bit so that it's convenient. Let's go back to our cloud run jobs. And there is a cleanup service. We will see how we can, this cleanup service is actually scheduled to run once every night. But since I wanted to show you, I'll actually force run this cleanup service quickly so that you can see how it actually goes and takes out the data, right? It runs the job, and once the job is complete, it actually stops. So for that, I'm actually going to invoke a job. Let me connect to this service. All right. I'm using Cloud Shell Editor. And let's see, the name of the service is cleanup service. So I'm invoking a Cloud Run beta run jobs. The reason it's beta is because this Cloud Run jobs it was introduced new. It is in preview right now, and in a few months it will get to the fully GA status. Right now it is in preview, so that's the reason why we are using gcloud beta. So I'm running the job with the name cleanup service, and this is actually in the region Europe West 9. The job is running in that region. So I'll invoke this job. Oops. I have to set the project. The project is set. So when I execute the job, I'm just forcefully executing instead of using the scheduler. The scheduler is already set to run this job once every day at 12 in the night. But now I'm actually running it myself. So it's provisioning the resources. So basically, it starts the job, it provisions the resources, and it runs. And you'll see that the logs are captured in the Cloud Console here, and it provides a link for us. So let's look at the logs. The job ran, and it's actually deleting certain menu items, right? So basically it is telling us that it is actually deleting the menu item so and so. So now let's go back and see which are the failed ones. I had a failed beet juice here for some reason. I have failed car that we created recently, but I set the duration to 60 minutes, right? If an item is either in processing status or failed status, but it was created within 60 minutes, it won't get deleted. Any older items will get deleted. So you can write your jobs with your own logic, and I have such a logic that only the ones that are older than 60 minutes should be deleted, right? So it has, now that the deletes are gone, all the failed items are gone, let's refresh the screen. Now we are more cleaner, right? So let's see. So other than the car that we just uploaded, all other failed items are now gone, right? So this is like, if you have lots of processing to do, I know that only a few items were supposed to be deleted and it didn't take much time. But if you have long running transactions like jobs and they take hours to run, that's where Cloud Run Jobs applies. So basically, with Google serverless technologies, you have several services, several technologies that are coming together that are allowing you to build enterprise-ready serverless applications, which can actually meet complex application requirements of your enterprise. Right? That's what we showcase with this sample application example. Now it's time for us. That was the end of the demo. So let's get on to the questions now. Give me 1 second. I'll stop sharing the screen. Yep. Let's look at the questions. I see a question from a user. How is Firestore connected to the employee UI? Is there a setting to enable to auto refresh, or is that out of the box? It is actually out. Basically, when Firestore has that ability to, the Firestore database has that ability to directly update the employee UI by pushing the notifications to the UI directly. That's a feature that comes with the Firestore kind of a database. That's the advantage you have. Yes. For what I'll do is we'll also post the URL for the code. It's all open source. I'll actually share with you the URL for the code, and maybe once in the chat session, if you can post this, ask this question of sharing the URL for the code, I'll share you the GitHub URL for the code, and you can actually look at that code. It is pretty much very sleek. Firestore has that ability to push the notifications. Other questions. Are we limited to only languages such as Golang, Node.js, Python, Java that you listed earlier to run with serverless on Google Cloud? No, you are not. Those are the technologies that will allow you to write your code, and a container is automatically created for you without knowing Docker, right? If you want to go with that approach, where you want to select a technology where build packs will be used to convert your code to a container, that's where those Golang, Node.js, Python, Java, and Ruby, right? That's another language that I listed earlier. Those will apply. But technically, you can actually bring any container and run in this environment. Are the serverless patterns you presented today the only ones that Google Cloud meets? No, actually, these are the patterns that we implemented in our in the sample application that I demoed you. In the interest of time, I only demoed a few features of that application, but coming back to the serverless patterns, those are the patterns we implemented, but there are many more patterns or many more usages of GCP serverless, the Google Cloud serverless technologies. If you are interested to learn more, please get in touch with us, and I'll send you an email. I'll share with you an email later, but basically get in touch with us, and we can work with you to meet your or to explain what other possibilities are there. So if your use cases are outside the scope of the patterns that I just showed you, don't worry about it. There are many more things we can do. These are just the examples of the things that we have implemented so far in that sample application. But our customers have used serverless in a lot more different ways. Next one, do you offer this enterprise serverless workshop to a large group of developers in our organization? Okay, let's get to the how we can help you with the serverless workshop in a minute. So let's get to the next steps. I see that there are no other questions, so we'll jump to the next steps part. So if you want to learn more about the enterprise serverless patterns and you want to get hands-on experience, basically what we offer is a hands-on workshop. It's at no cost. So what we do is every pattern that you have seen in that architecture, you can actually implement it yourself using quick labs, and you learn it on your own. And by the end of, like, it takes about 4 hours or so, but by the end of those 4 hours, you'll learn how to build an application, the example that I showed you, right? So we implemented that as an enterprise serverless workshop. So doing such a workshop, you'll get a full-fledged understanding of how to use Google Cloud's serverless technologies to build your applications. We actually offer this workshop to a bunch of developers. So if you have a group of developers who want to get trained on this workshop, it could be developers or application architects, even the project managers who want to understand how this enterprise serverless technology works. You can bring all of them together and ask for this workshop. Note this email address that I'm sharing here, esw-request@google.com. I'll give you a minute to note it down. So this is where you would send an email in case you are interested in this workshop. We'll get in touch with you and we'll offer the workshop and coach your team on how to build such applications. I hope that answers that last questions that you are asking about the workshop itself. So if you noted down this email, we will move on. And I see that the other question about the GitHub, I'll share the GitHub URL. I think we'll post a reply for the GitHub URL in the answer section. Oh, there are 2 more questions. Sorry, I just noticed them. Can we interact with Cloud? Can we interact Cloud Run with App Engine? I believe you're talking about, can we integrate Cloud Run with a Cloud Run service with another application that is running on App Engine? Yes, you can. You can Cloud Run. Let's say you build a microservice that runs in Cloud Run, and you have another service that is running on App Engine. It is just a simple application to application call. Think of it as a microservice calling another microservice. No big deal there. You can do that. Next question. I'm a mainframe developer and planning to switch with Google Cloud platforms. Could you please let me know the approaches? So if you go to cloud.google.com and search for serverless technologies, there is lots of material there, right? And you can self-coach yourself. That's one approach if you want to get trained. The other is there are education programs. Again, you can find them on Google Cloud's website, where you can do certifications on Google Cloud and learn the serverless technologies. The third, let's say you have a bunch of developers in your organization who are interested specifically about the enterprise serverless workshop, where you can learn hands-on on how to use Google Cloud serverless, right? We can teach you that. There is it's more of how do you configure or use the serverless technologies than code there. So basically, the for example, Java code or Node.js code or anything that is needed to build the application is already given to you. So we are not trying to teach you how to write Java code or Node.js code and things like that. That's out of the scope. It is more about how do you take some code and how do you deploy that as a cloud run application? How do you write some code and then use it as a function? How do you put event-driven processing pipeline together? These are the kinds of, how do you secure your cloud run services? These are the kinds of things we teach as part of that workshop. So to answer your question, in case you have a group of developers who are interested in getting onboarded, let us know. You saw that email and we can help you with that. That seems to be the end of questions. So let's and you noted the next steps. So that's good. So what else? Good stuff. So thanks a lot. Thanks for joining us today. If you are interested and you want to see the list of upcoming Google Cloud Innovators events, you can visit https cloudonAir/google.com/cloud innovators. Make a note of this URL, register yourself for the upcoming sessions, and you will be good to go. Thanks for coming again.